Parvati, Ashwini, Gauri, Fadia. Good morning, everyone. Janaki, Lakshmi, Ashwin, Anjana, Siddharth, Chandana, Alka. Once again, good morning, everyone. So, yesterday we discussed about the direction ratios and direction cosines of a line in a space and how to write the equation of a line in a space when a point on the line and a vector which is parallel to the line are given to us. So let us do some more problems. You can write the question. Find the equation of the line in vector and in Cartesian form. In vector and in Cartesian form that passes through the point with position vector (2i minus j plus 4k) and is in the direction I plus 2j minus k. Find the equation of the line in vector and in Cartesian form that passes through the point with position vector 2i minus j plus 4k and is in the direction I plus 2j minus k. See, let us recall how we have to write the equation of a line. In vector form, vector r is equal to vector a plus lambda vector b. This is the vector form, and in Cartesian form it is x minus x1 by a equals y minus y1 by b equals z minus z1 by c. So you have to remember this x1, y1, z1 is the point through which the line passes, and A, B and C are the direction ratios of the vector which is parallel to the given line. Okay, once again, see, vector A is the position vector of the point. Position vector of the point through which the line passes. To write the position vector of a point, the coordinates of the points are given here, x1, y1 and z1. So the position vector is x1i plus y1j plus z1k. Okay, then plus this vector b is a vector which is parallel to the given line. And the direction ratios of this b, vector b, are given by a, b and c. So you have to identify from this what are x1, y1, z1 and what are a, b and c. What are the values of x1, y1, z1 and what are the values of a, b and c. Can you give the answer? See, A is the position vector of the point and the coordinates of that point are x1, y1 and z1. Now read the question and find out the values of x1, y1 and z1. Give your answer. What is the value of x1? We have to write the equation of a line which passing through the point and the position vector of that point is given as 2i minus j plus 4k, or you can write the coordinates of the point are 2, minus 1 and 4. From here you are getting it. The position vector of a point is 2i minus j plus 4k. So the coordinates of the point are 2, minus 1 and 4. And the line is parallel to or in the direction of means it is parallel to the vector I plus 2j minus k. So the direction ratios of this vector are 1, 2 and minus 1. These are the direction ratios of the vector. So what are the values of x1, y1 and z1? Give your answer. What is the value of x1? x1 is equal to 2. Then what's the value of y1? x1 is equal to 2. See, this is the point through which the line passes. So this point is x1, y1, z1. That is x1 is equal to 2, y1 is equal to minus 1 and z1 is equal to 4. Okay, then now we need this A, B and C. A, B and C are the direction ratios of the vector B which is parallel to the line. So here the direction ratios are 1, 2, minus 1. So A is equal to 1, B is equal to 2 and C is equal to minus 1. So we can write the equation of the line in vector form. In vector form is vector r is equal to a plus, a means the position vector of the point, it is already given here, 2i minus j plus 4k plus lambda into vector b is given as I plus 2j minus k. So this is the vector equation, and now the equation of the line in Cartesian form is equation of the line in Cartesian form is x minus x1 is 2 by a is 1. This is equal to y minus y1 is minus 1. So it is y plus 1 by b is 2. This is equal to z minus z1 is 4 divided by c is minus 1. So this is the equation of the line in Cartesian form. Is it clear? The only thing you have to take care here is vector A is the position vector of the point through which the line passes, and its scalar components give, that is x1, y1 and z1 are the scalar components that are the coordinates of the point. Now vector B is a vector which is parallel to the line, and vector B is given as AI plus BJ plus CK. A, B and C are the direction ratios. Okay, now we can move to the next one. Find the Cartesian equation of the line which passes through the point -2, 4, -5. -2, 4, -5 and parallel to the line given by x plus 3 by 3 equals y minus 4 by 5 equals z plus 8 by 6. X plus 3 by 3 equals y minus 4 by 5 equals z plus 8 by 6. Okay, see now in the question it is given that we have to write the equation of a line that passes through the point -2, 4 and -5. Passes through the point -2, 4, -5. So what are these values? x1, y1, z1 or a, b, c. These are x1, y1 and z1. So we can write this as x1 is equal to -2, y1 is equal to 4 and z1 is equal to -5. So this is the point through which the line passes. So this is to be taken as x1, y1, z1. Now to write the equation of the line, we need the direction ratios. Now listen, here you have to write the equation of this line L, and and given that this line passes through a point -2, 4, -5. So we wrote it as x1, y1, z1. Now it is given that this line is parallel to another line. Parallel to another line here. So another line is given. This is, let us consider this as M. Can you say the point through which this line passes? See, this is of the form x minus x1 by a equals y minus y1 by b equals z minus z1 by c. So since we consider x1, y1, z1 as a point on this line, let us take this as x2, y2, z2. So a point on this line is given by -3, 4, -8. Isn't it? See, this is the point here, x minus -3, y minus 4, z minus -8. So a point on this line is -3, 4, -8. And what about this 3, 5 and 6? What are these values? 3, 5 and 6 are the direction ratios of a vector which is parallel to this line M. Okay, this is a vector B which is parallel to the line M, and it is given that this is equal to 3i plus 5j plus 6k. Okay, so 3, 5, 6 are the direction ratios of a vector which is parallel to this line. So whenever you see an equation like this, you have to identify that this line passes through the point -3, 4, -8, and the direction ratios of a vector which is parallel to it is 3, 5 and 6. See here, M is parallel to L. So this vector B is parallel to L also. So the direction ratios of this B can be considered as the direction ratios for this L, for this line L also. Okay, so we can take A is equal to 3, B is equal to 5 and C is equal to 6. A is equal to 3, B is equal to 5 and C is equal to 6. Now we can write the equation. Question is find the Cartesian equation of the line. So you have to write the equation. Equation of the line is x minus -2 by A is 3. This is equal to y minus 4 by B is 5, which is equal to z plus 5 divided by 6. X minus x1 by A equals y minus y1 by B equals z minus z1 by C. So how can you write the vector form from this? If you have to write the equation of the line in vector form, how can you write it from here? See, this equals 2i, it is -2i, then plus 4j minus 5k plus lambda into 3i plus 5j plus 6k. This is the vector form. -2i plus 4j minus 5k plus lambda into 3i plus 5j plus 6k. This is the vector form. Okay, now the next one. The Cartesian equation of a line is x minus 5 by 3 equals y plus 4 by 7 equals z minus 6 by 2. Write its vector form. Write its vector form. X minus 5 by 3 equals y plus 4 by 7 equals z minus 6 by 2. Give your answer. Vector equation of the line is give the vector form corresponding to this. Okay, 5y minus 4j plus 6k, 5y minus 4j plus 6k plus lambda into 3i plus 7j plus 2k. Okay, it is 5i minus 4j plus 6k, 4j plus 6k plus lambda into, this is vector a plus lambda b. Lambda b is 3i plus 7j plus 2k. So this is the vector equation. Okay, 5i minus 4j plus 6k plus lambda into 3i plus 7j plus 2k. Okay, let us do another one. Write the Cartesian equation of a line vector r equals minus 3i plus 5j minus 6k plus lambda into 2i plus 4j plus 2k. 2i plus 4j plus 2k. How can you write this equation in Cartesian form? Okay, it is x minus x1. X minus x1 is minus 3, so it is x plus 3 by a is equal to 2, which equals y minus y1 by b equals 4. This equals z minus 6 by 2. So this is the Cartesian equation of the line. X plus 3 by 2 equals y minus 5 by 4 equals z plus 6 by 2. Is this clear? When a point on the line and a vector which is parallel to the line is given, how can we write the Cartesian equation and vector equation of the line? So now we are going to write the equation of a line. Next is second one. The equation of a line which passes through two given points. Which passes through two given points. Here also you have to write the vector equation and also the Cartesian equation. See, in the first case, we have to write the equation of a line which passes through a given point and a vector which is parallel to the line is given to us. Here, two points through which the line passes. So let us consider two points, say A, x1, y1, z1, and another point B, x2, y2, z2. Okay, x2, y2, z2. So a line joining these 2 points. Just consider the xy plane here. Two points, one A, x1, y1, z1 and B, x2, y2, z2 are given. So here the position vector of this A is, we can join these two and let this vector be equal to A. This vector as B. This OA is vector A and OB is to be taken as vector B. Let us consider any arbitrary point P, XY on this line, XY, Z on this line, and let this OP, vector OP is equal to vector R. Okay, so in component form we can write this vector A as x1i plus y1j plus z1k. Then vector r equals xi plus yj plus zk. See, this P is any arbitrary point on this line and we consider its coordinates as x, y, z. So the position vector of P is given by OP and it is written as R. This is equal to xi plus yj plus zk. Similarly, vector B. Vector B is the position vector of the point B and it is given by x2i plus y2j plus z2k. See, when we apply triangle law of addition here, OA plus AP is equal to OP. So it is vector OA plus AP is equal to OP. That is, this R can be, OP is vector R, OA is vector A. This is this vector A plus vector AP is equal to R, or you can write vector AP as R minus A. This vector AP is equal to R minus A. Similarly, we can write this OA plus AB is equal to OB. Vector OA plus AB equals OB. And that is A plus vector AB is equal to vector B, or vector AB is equal to B minus A. See, now we are applying triangle law of addition here. First we are considering this triangle OAP, and here OA plus AP is equal to OP, and OA is vector A plus AP is equal to R. So AP can be written as R minus A. When we consider the triangle OAB, in this OA plus AB is equal to OB. So you can write the vector AB as B minus A. See, in this AP and AB are collinear vectors or parallel vectors. See, AP and AB are collinear vectors or parallel vectors. Collinear vectors or parallel vectors, that means one is the scalar multiple of other. So we can write this as AP is equal to lambda into AB. Okay, one is the scalar multiple of the other. AP is equal to lambda into vector AB, or you can write this AP as R minus A is equal to lambda into B minus A, or from here you can write vector R is equal to vector A plus lambda into vector B minus A. This is the vector form of the equation of a line which passes through two given points. This is the vector form. Vector R is equal to A plus lambda into B minus A. Compare with the first one. In the first case, when a point A and a parallel vector is given, you are writing the equation as R is equal to A plus lambda B. Okay, here it is A plus lambda into B minus A. Consider any point on the line whose position vector is A, and then lambda into B minus A gives B is the position vector of one point and A is the position vector of the other point. And you know that to find this direction ratios of AB, it is x2 minus x1, y2 minus y1, z2 minus z1 are the direction ratios. The same we are writing here, x2 minus x1 b minus a, which gives x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 k. Is this clear? Okay, now see here we can write this R in component form, xi plus yj plus zk, which is equal to A can be written as x1i plus y1j plus z1k plus lambda into this b minus a we can find from here, x2 minus x1i plus y2 minus y1j plus z2 minus z1k, and equating the corresponding scalar components. That is equating the coefficients of I, equating the coefficients of j, and equating the coefficients of k, and finding the value of lambda from each of this. We can write the equation as x minus x1 by x2 minus x1 equals y minus y1 by y2 minus y1 equals z minus z1 by z2 minus z1. This is the Cartesian equation of a line which passes through 2 points x1, y1, z1 and x2, y2, z2. So in the first case, the equation was x minus x1 by a. A is the direction ratio and it is x2 minus x1. B is y2 minus y1. C is z2 minus z1. Really both are same, but we are writing it in different form. So the vector form is vector R is equal to A plus lambda into vector B minus vector A. This is the vector form, and the Cartesian form is x minus x1 by x2 minus x1 equals y minus y1 by y2 minus y1 equals z minus z1 by z2 minus z1. So let us do some problems. Find the vector equation and Cartesian equation of the line that passes through minus 1, 0, 2 and 3, 4, 6. Minus 1, 0, 2 and 3, 4, 6. So 2 points are given to us. We can consider this as x1, y1, z1, and this is to be taken as x2, y2, z2. So first let us write the vector form. vector form you have to write as vector r is equal to A is the first point. So you can write this as minus I plus 2j. The position vector here is minus 1I plus 0j plus 2k. Sorry, it is 2k. Minus 1I plus 2k plus, see the here it is lambda into vector b minus vector a, that is 3x2 minus x1, 3 minus minus 1, it is 4I plus 4 minus 0, it is 4j plus 6 minus 2, it is 4k. This is the vector form of the line. And the Cartesian form can be written as, Cartesian form is x minus x1 is minus 1 by x2 minus x1, it is 4, which is equal to y minus 0 by y2 minus y1, which is 4. Again this is equal to z minus 2 by z2 minus z1, that is 4. So this is the Cartesian form of the line. Is it clear? Okay, then let us do another one. Find the vector and Cartesian equations of the lines. Vector and Cartesian equations of the lines that passes through the origin and 5 minus 2 3, 5 minus 2 3, passes through the origin and 5 minus 2 3. Can you give the answer? First write the vector form. Vector r is equal to give your answer. First one, vector form passes through the origin. So one point is origin and the second point is 5 minus 2 3. Okay, the first part is 0 since it is origin, then plus lambda into, so you can write this as lambda into 5y minus 2j plus 3k. So this is the vector equation of the line, and now the Cartesian form. Okay, it is x by where are the others? Lakshmi, give your answer. Chandana, give your answer. Nakshatra, Srinandana. So okay, Cartesian form is x by 5 equals, since x1, y1, z1 are 0, 0, 0, x minus 0 by 5 minus 0 equals y plus, sorry, y minus 0 by minus 2, which is equal to z minus 0 by 3. So this is the Cartesian form. Now the next one is find the vector and Cartesian equations of the line. Find the vector and Cartesian equations of the line that passes through the points (3 minus 2 minus 5) and 3 minus 2 6. 3 minus 2 minus 5 and 3 minus 2 6. Srinandana, Gauri and Aparna Das, give your answers. First write the vector form. Janaki, give your answer. So it is 3i. This is to be taken as the first one, 3i minus 2j minus 5k plus lambda into b minus a. That is 3 minus 3, it becomes 0. Minus 2 minus 2, it becomes minus 2 minus 2, it becomes 0. 6 minus minus 5, which is 11k. So this is the vector form. Now the Cartesian form is Ashwin, give your answer. So it is x minus 3 by x minus 3 by 0 equals y plus 2 by 0, which is equal to z plus 5 divided by 11. So this gives the Cartesian form. Is it clear? Okay, now let us move to the next topic. Angle between two lines. Angle between two lines. See, to find the angle between two lines, R equals a1 plus lambda b1. This is one line. Next line is r is equal to a2 plus lambda b2. Vector form of two lines are given here. So to find the angle between these two lines, it is enough to find the angle between the two vectors b1 and b2. Find the angle between vectors b1 and b2. See, this line r is parallel to vector b1 and the second line r is parallel to vector b2. So to find the angle between these two lines, it is enough to find the angle between the vectors b1 and b2. You know how to find the angle between two vectors. How can you find the angle between two vectors? How can you find the angle between two vectors? Cos theta equals modulus of b1 dot b2 by modulus of b1 into modulus of b2. This we had learned in vector algebra. Using the scalar product or dot product, we can find cos theta is equal to b1 dot b2 by modulus of b1 b2, or you can write this as CB1 is taken as a1i plus b1j plus c1k and b2 is taken as a2i plus b2j plus c2k. These notations you have to remember. Parallel vectors, the scalar components are taken as a, b and c. So here we are writing it as a1, b1, c1, a2, b2, c2. When we are considering the vector a1 and a2, this is x1i plus y1j plus z1k and this is x2i plus y2j plus z2k. That are the notations used. Okay, now this modulus of b1 dot b2 by modulus of b2 b1 into modulus of b2. So this can be written as, how can you find the scalar product here when it is given in component form? What is b1 dot b2? From here, what is b1 dot b2? It is a1 a2 plus b1 b2 plus c1 c2. To find the dot product of this, take the product of the scalar components. Okay, a1 a2 plus b1 b2 plus c1 c2 divided by, what is modulus of b1? It is root of a1 square plus b1 square plus c1 square into root of modulus b2 is a2 square plus b2 square plus c2 square. So you can find angle theta from here, from these two. Just remember how we are getting this formula. B1 and B2 are the parallel vectors. We have to find the angle between them. To find the angle between them, A1 A2 plus B1 B2 plus C1 C2 divided by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. That is equal to cos theta. So you can find theta from it. And also two lines with direction ratios A1, B1, C1 and A2, B2, C2 are perpendicular if you don't know that two lines are perpendicular when B1 dot B2 is equal to 0. That is A1 A2 plus B1 B2 plus C1 C2 is equal to 0. This is the condition for perpendicularity of two lines. A1 A2 plus B1 B2 plus C1 C2 is equal to 0. And the second one is two lines are parallel if A1 by A2 is equal to B1 by B2 is equal to C1 by C2. That is, the direction ratios are proportional. So these are the conditions for perpendicularity and parallelism for lines. So you have to compare with the standard form of equation of a line. R is given as A plus lambda B. You know that A is the position vector of a point through which the line passes, and B1 is a vector which is parallel to this line. Here A2 is the point through which the line passes and B2 is a vector which is parallel to the given line. To find the angle between them, we have to find cos theta equals B1 dot B2 by modulus of B1 into B2. And if this B1 dot B2 is equal to 0, then the lines are perpendicular. And if the direction ratios, that is A1 and A2, B1, B2, C1, C2 are proportional, that is A1 by A2 is equal to B1 by B2 is equal to C1 by C2, then the two lines are parallel. Is it clear? Okay, then we will do the problems related to this in the next class. Thank you.